Okay, so polygons is just another topic which comes under the heading of geometry only. And if you may talk about the definition of polygons, so definition is polygons are close-sided figure. Closed-sided figures. So for this whole definition, close-sided is the most important keyword. Why? Because if I may talk about a three-sided figure, three-sided figure. So three-sided figure, it's an incomplete statement. Why? Because three-sided figure can be this also, which doesn't make any sense, which is not any geometrical shape. But if I say a three-sided closed figure, now it makes sense. So three-sided closed figure, it's a triangle. So for polygons, these have to be close-sided figure. Now, for polygon, usually there are three-sided till 10-sided polygons, which we need to know along with their names. So I'm writing a few common polygons whose name you should be knowing before we start this topic. So on one side, I'm writing the number of sides involved, number of sides, and along with their number of sides, their respective names. So if I talk about, and yes, the minimum size to make a closed figure is 3. You cannot make a closed figure with 2 sides. So that means a polygon, it starts with a minimum of 3 sides. So a 3-sided polygon we call as triangle. A 4-sided polygon, it's called as a quadrilateral. And about triangle and quadrilateral, we have already done a lot of questions in the previous classes. A 5-sided figure, it's called a pentagon. A 6-sided figure is called as a hexagon. 7-sided, it's hectagon. 8-sided is octagon. Remember, octopus is also having 8 legs. So octopus, OCT, oct has been taken from this word octagon only. 9, it's nanogon. And 10, it's decagon. And for this word decade, decade means 10 years. So DEC of decade has been taken from decagon only. So decagon, it's DEC, it's a prefix for this 10-sided polygon. So these are the common polygons along with their names you should be knowing, which we can expect in exams and the books as well. All right, now we know that for a triangle, when we say triangle, so triangle, we know that sum of triangle, it's 180. Sum of triangle. When we say sum of triangle, that means sum of all 3 angles. So sum of triangle, it's 180. When we talk about quadrilateral, it's a 4-sided figure. So when we talk about quadrilateral, the sum of quadrilateral, that means sum of all 4 angles inside a quadrilateral, that is 360. But what if we have a 5-sided figure whose sum we need to know? A 6-sided figure whose sum we need to know, that what should be the sum of all 6 angles inside the hexagon. So for this, we have a couple of formulas to be remembered. And before looking at the formula, we should be knowing the couple of terms which we call as the interior and the exterior angle. So if I make a triangle, for example, triangle, we know that it's a polygon. So we are taking triangle representing a polygon generally. So if it is a triangle which is a polygon, and I am extending this side of a triangle. And I'm naming this as A, B, C, and D. Now for this triangle and this extended side BD, we have three interior angles. These are all interior angles. Interior angles means the angles inside the polygon or the angles inside the closed figure. So we have three interior angles here. So this angle is an interior angle. And then we have one more term which is called as the exterior angle. Exterior angle is the angle formed outside the interior angle. And this is always obtained when you extend one of the lines of the interior angles. I am using the word extend. Extend means this has to be a straight line. ABD, in this case, it would be a straight line. ABD, it's a straight line. And since it's a straight line, so you should be applying the properties of a straight line here. That means the interior and the exterior angle, they would be supplement to each other. Supplement to each other means they would add up to 180 degrees. So if this angle we have interior angle, if this angle is A, for example, and exterior is B, so A and B, they should sum up to 180 degrees. So that's an important property about polygons. So A plus B, in this case, they would add up to 180. Another way of writing it is the sum of interior and exterior is 180. Interior plus exterior is equal to 180 degree. That's the first property to be remembered about polygon. We should be knowing what is the difference of interior and exterior. Now, the next thing to be remembered about interior angle is the sum of interior angles. Sum of interior angles. When I say the word sum of interior, that means it can be for a quadrilateral, it would be the sum of all four interior angles. When I say pentagon, pentagon means sum of all five interior angles. When I say hexagon, hexagon means sum of all six interior angles. So sum of interior angles. So for a polygon, the formula for sum of interior angles, this is n minus 2 into 180. Where n represents the number of sides. N represents number of sides. And then we know that we have exterior angles also. So for exterior angles, sum of exterior angles. No matter what polygon it is, either it's a 4-sided, 5-sided, 10-sided, 20-sided, 25-sided, no matter how many sides are there, the sum of exterior angle will always be 360. So you simply, there's no formulation behind it. It's only the sum of exterior. Sum of exterior angles. This is always equal to 360. So this is the third formulation or third property to be remembered about polygons. The next thing to know is the term regular polygon. Regular polygon. Now, there's an important difference between a polygon and a regular polygon. When the question uses the word polygon, so for polygon, it is any close-sided figure. But when we say a regular polygon means it has to be a close-sided figure, but it's a special type of polygon in which all sides and all interior angles, they are same. For example, if I may talk about quadrilateral. Now, quadrilateral, we know that quadrilateral is a four-sided figure. And for quadrilateral, we know that trapezium, it's a quadrilateral. We know that uh, parallelogram, it's a quadrilateral. We know that rhombus, it's a quadrilateral. But when we say regular quadrilateral, so regular quadrilateral is only one. When I say regular quadrilateral, so regular quadrilateral is only one. Out of all those quadrilaterals whose name I've taken, regular quadrilateral is only one, which is a square. Because a square is the only quadrilateral in which all four sides are equal in length and all four interior angles are also same, which is 90 degrees. The word regular holds a very important significance. So that means when it's a regular polygon, we can always find each angle of a polygon. So if we have to find each angle of regular polygon, we know that the sum of interior angles is already n minus 2 into 180. Now, since for a regular polygon, all the angles are same, and we have to find the value of one angle, so we'll simply divide the sum by the number of sides or the number of angles. So in the numerator, n minus 2 into 180, that represents sum of all interiors. And since all interior are same, so we can find the value of each interior by dividing the sum by the number of angles. So this is the formula to be used when the question uses the word regular polygon. So that makes it the fourth important property or thing to be remembered about polygons. And of course, we have talked about interior. This is for interior, each interior. And there should be a property associated with the exterior angles also. So if we have to find each exterior angle of regular polygon. So we have already discussed that sum of exterior is 360. That means if it's a pentagon, a five-sided figure, so for a pentagon, all five exteriors should sum up to 360. But if it's a regular pentagon means all five exterior will be same. So we simply divide the sum by the number of angles to have the value of each angle. So each exterior, in this case, it would be 360 divided by n. 360 divided by n. That is the fifth last property or the formulation associated with this topic, polygons. Okay, now we'll solve a few examples about polygons. In the very first example, the question says find the sum of the interior angles of a polygon with 7 sides. We have to find sum of interior angles of a polygon. So the question doesn't use the word regular polygon here. It is only asking us for the sum of interior. So we know that sum of interior angles is equal to n minus 2 into 180. And here represent the number of sides, which in this case of part A, that is 7. 7 minus 2 into 180, which is 5 into 180. And that would give us 900. So sum of 7 interior angles, that would be 900. And same thing we'll do for 17 sides. For 17 side, we'll simply substitute n as 17 in the same formula. So you can try this yourself later. Okay. In this example, the second example, yeah, this. So in this example, we have to find the value of C. And if we look at this figure, it's a 5-sided closed figure. 5-sided closed figure means it's a pentagon for us. And we don't know what is the sum of all 5 angles. If we know the sum of all 5 angles, I mean sum of 5 interior angles inside this pentagon. If we know the sum, we can easily make the equation that will help us in finding the value of C. So to make up an equation, we need to know the sum of 5 interior angles. And for that, we'll use the sum of interior angles formula. So sum of 5 interior angles is equal to, we know that the formula is n minus 2 into 180. So since n is 5 here, it would be 5 minus 2 into 180. And that would be 3 into 180, which is a 540. So that means all these 5 angles inside the pentagon, they should sum up to 540 degree. Like the case of triangle, all 3 angles sum up to 180. For quadrilateral, all 4 angles sum up to 360. For pentagon, all 5 angles should sum up to 540. So all 5 angles means we'll make the equation as the first angle as 120 plus 65 plus 130 plus 2C minus 15 plus C. These are the 5 angles and they should sum up to 540. So here we have got the equation made. And in this whole equation, you can clearly see it's only the variable C which is unknown and that needs to be found. So we'll solve it so that we have 120 plus 65 plus 130. That is 315. And minus 15 also. So minus 15 also, it will give us 300. So 300 plus 2C plus C, that's a 3C is equal to 540. Finally, 3C is equal to 540 minus 300. That's a 240. And C is equal to 240 divided by 3. That's an 80 degrees. So we got AC as 80. This was the second example. Moving onwards. Now this question is from the past papers. Again, it's a hexagon. And here it says this hexagon represents the front of a house with 2 right angles. 2 right angles. One important term. 2 right angles means this is 90 as well as this one. The other 4 angles are all same size. All same size means if this is x, so this will also be x, x, x. All four angles are same, so that means we can keep variable x for all four angles here. Now, since it's a hexagon, unlike the previous question where it was a pentagon, we found the sum of all five angles first to make up the equation. Here it's a case of hexagon, so we'll use the sum of interior angles formula here to find the sum of six angles for this hexagon first. So we start with the same formula, which is n minus 2 into 180. So sum of six interior angles is equal to n minus 2 into 180. And it's a 6 here. So it would be 6 minus 2 into 180. And that gives us 4 into 180. So 4 into 180. That's a 720 degrees. So we get the sum of six interior angles as 720. And this will help us in making the equation to find the required angle x. So sum of six angles means the six angles we have is 90 plus 90. And since all four angles are x, so we can write 4x for it. And they would sum up to 720. So 4x is equal to 720 minus 180. And 4x is equal to 720 minus 180. That gives us 540. So we get x as 540 upon 4. X is 135. So we get each angle as 135. We are supposed to find one of these angles. So one angle is 135. Any questions up till here? Anything which is not clear? Okay, I don't see any questions. Let's move on. Another question taken from the past paper. Here it says five angles of a hexagon. They are using the word hexagon. Are each 115. Calculate the size of the sixth angle. So we have already solved the case of hexagon here. So we can take a help from this question. We know that sum of hexagon or sum of six angles is 720. So we'll do a shortcut here. We'll make the equation as sum, that is sum of six angles. We know that is 720. And out of those six angles, we have five angles of 115. And we have to find the sixth one. So five angles, these are of 115. So we can make the equation as 5 into 115. And the sixth angle is unknown, so we are keeping a variable x for it. All these six angles should sum up to 720. So on the other side, we have 720. So we have got the equation made here. So 5 into 115, that's a 575. So 575 plus x is equal to 720. And then x would be equal to 720 minus 575. So we get this as 720 minus 575, which is 145. So the sixth angle for this hexagon, the sixth angle for this hexagon, it's 145. All right, so we have solved a couple of questions based on the term polygon only. Now we'll do a few questions where we have the use of the word regular polygon. Regular polygon. So the question says we have to find the number of sides of a regular polygon if each interior angle is 108. Since the question is about regular polygon means all the angles are same. So here the value of each angle is given, which is 108, and the number of sides are unknown. We'll start with the same formula for regular polygon, and we know that the formula is each interior angle that is equals to n minus 2 into 180 upon n. And n is something what we need to find here, the number of sides. Each interior angle value is given, which is 108. So 108 is equals to n, we don't know, upon n. And now we have to use a bit of algebra here. And for that, we do some cross multiplication. So 108 into n, that would give us 108n is equals to 180 into n, that's 180n minus 360. And further, we'll do 180n minus 108n is equals to 360. 180 minus 108, that is 72. So 72n is equals to 360, and n is equals to 360 upon 72. We are getting this as 5. Part B is still the same. Again, we have been given with the each interior angle, which is 156. So we start with the same formula, each interior angle is equals to n minus 2 into 180 upon n. Each interior angle, that is 156, is equals to n minus 2 into 180 upon n. Here again, we'll do some cross multiplication. So 156n is equals to 180n minus 360. And 360 is equals to 180n minus 156n. So 24n is equals to 360. N is equals to 360 upon 24. That is 15. So it's a 15-sided figure. So this example was about regular polygon where we were supposed to find the unknown side. Remember, it's a case of unknown side. Unknown sides for a regular polygon. And this type of question comes quite oftenly in past papers, especially without calculator. A similar example, but the only difference here, the previous question, it was about interior angle of a regular polygon. And this question, it's about exterior angle of a regular polygon. So since it's about exterior angle of a regular polygon, so we have to start with the exterior angle formula. Because here again, we have to find the size of each. So here the number of sides are given. So n is equal to 6. And we have to find each exterior. So each exterior angle, formula was each exterior is equal to 360 upon n. So each exterior in this case, it would be 360 upon 6. So we get each exterior as 60 degrees. And part B is similar, that you can do it yourself later. Okay. Question number 18. The exterior angles of a pentagon are this, this, and this. We have to find the value of x. Guys, I want you people to try solving this question yourself. You have 5 minutes of time, so please solve this. Okay, so for the first part, the correct answer is 30. And for the second part, the correct answer is 80. Moving onwards, this is another past paper question. And here again, it's using the word regular polygon. So this question, it talks about diagram shows a regular octagon joined to an equilateral triangle. So there are two important terms to be highlighted. It's a regular octagon and it's an equilateral triangle. Equilateral triangle means all three angles are 60 degrees. So this is 60 as well as this one and this one, because it's an equilateral triangle. And we have to find this value of x. To have this value of x, if somehow we manage to find this part, we can call this as y. If somehow we manage to find y, then we know that at one single point, all the angles, they sum up to 360 degrees. So this is how we can make the equation to find x. But before making this equation, our focus should be on finding y first. It's a regular octagon. So we can find each interior angle of a regular octagon using the formula. So each interior angle of octagon. Octagon, we know that it's an 8-sided figure. So n would be 8. So that's 8 minus 2 into 180. And since it's a regular octagon, that means it has to be divided by 8. We get this as 6 into 180 upon 8. So each interior angle, that would be equals to 6 into 180 divided by 8. So that's 135. We get this y as 135. And using the property of point on a angles on a single point, they sum up to 360. The angles on a single point, we have three different angles on this single point, which is x plus y plus 60. They should all sum up to 360. Y, we have found this as 135. So x plus 135 plus 60, that adds up to 360. x plus 135 plus 60, that is 195. X is equal to 360 minus 195. That's 165. So X is 165 here. We have this another past paper question here. And this one again, I want you people to give it a try. Try to solve it and let me know what is the answer. Okay, the correct answer is 60. Those who are not able to get the correct answer, please pay attention. Now, always remember interior and exterior, they always lie on the straight line. Straight line means both these angles, they are supplement to each other. Supplement to each other means because of straight line, they should add up to 180. So the first equation to be made is 29x plus x, they should add up to 180. So we get 30x is equal to 180, and that gives us x as 180 divided by 30, which is which gives us x as 6. But we are supposed to find the number of sides of this polygon. So to find number of sides, this interior angle, which was 29 times x, this would eventually become 29 times 6. So each interior angle, that is 29 times 6, which is 174. So we get each interior as 174. And now to find, and it's a regular polygon, keep this thing in mind, it's a regular polygon. Since it's a regular polygon, so now we'll use a regular polygon formula. So each interior angle, that is equal to n minus 2 into 180 upon n. Each interior we found as 174. 174 is equal to n minus 2 into 180 upon n. And now we'll do some cross multiplication here. So it would be 174 into n, that is 174n minus 180n minus 360. So it would be 180n minus 174n is equal to 360. So that gives us 6n is equal to 360, and n is equal to 360 upon 6, which gives n as 60. So it's a 60-sided regular polygon. We'll do one more question and we'll end the class. This is again a question taken from the past paper. So here again, I want you people to give it a try. Please solve this. Okay, the correct answers are for the first part 24, second part 3960. So the equation to be made here, it says interior angle is 11 times the exterior. We don't know what is the exterior. We suppose the exterior as x. And we know that interior and exterior, they always lie on the same line. So this is exterior, which is x. Interior is 11 times. So 11 times means this interior, it would be 11x. And since interior and exterior, they lie on the same straight line, they should add up to 180. The interior angle is equals to 11x. And interior and exterior, they add up to 180. So 11x plus x is equal to 180. That's 12x is equal to 180. X is equal to 180 upon 12. We get x as 15. So, but the interior is 11 times x. So interior, that would be 11 times 15, which is equals to 165. So that means each interior is 165, and to find the number of sides, since it's a regular polygon, it's a regular polygon. So we'd use interior angle formula for the regular polygon. So each interior, that is equals to n minus 2 into 180 upon n. That's 165 is equals to n minus 2 into 180 upon n. Cross multiplication, that's 165n is equal to 180n minus 360. So 360 is equal to 180n minus 165n, which is 15n is equal to 360. So n is equal to 360 upon 15, which gives us 24. So it's a 24-sided regular polygon. This was the answer, part 1. Sum of interior angles. Sum of interior angles. So sum of interior angles is only this part, n minus 2 into 180. So part 2, we have to find sum. That is n minus 2 into 180. N is 24. So 24 minus 2 into 180. So that is 22 into 180, which is 3960. So this was about the second part. This was all about the polygons, and geometry as a whole is done. We have covered all the subtopics under the heading of geometry. And these were a few past paper questions about polygon, because generally polygons are the ones where students struggle the most. So along with explanation, we have done past papers also. So this was all about geometry.